right, so the last bit of this lesson is we're going to talk about what happens whenever data is transformed, when it's changed. Okay, so let's take, for instance, salaries. Maybe you were taking a look at salaries across the board at a certain company, and all of a sudden, all the salaries are changed. They decide to increase everyone's salary. Okay, so using addition. So if I take a look at this scenario, let's say, I don't know, for instance, everyone they're going to add $3 to everyone's pay. So if you made 24, now you make $27 an hour. They're adding a certain amount to every single person. Okay, now how it affects your data is going to be different. Remember, we have measures of center, mean, median, and mode, and we have measures of variation. Range and standard deviation are two examples. So if we're talking about measures of center, instead of going back through and calculating it all, maybe we have a list of 100 employees, right? We don't want to have to go through. We just found, even with a computer necessarily, but we just found mean, median, and mode. We don't want to have to go through, now that we found out, oh, they just changed it. Everyone now gets $3 more. We don't want to have to calculate what the new values are and then find mean, median, and mode again. Instead, the measures of center for the new data set is just found by adding this value k, which is what we're considering we add. So in this case, k is 3. We just add that to each of our measures of center. So we would take our mean, whatever it was. Let's say again, all right, let's say we have a sample person and they're making $24. Okay, when they add 3, now they make $27. That was a sample person. Let's say our mean was, if it was $30, well, now it's $33. Okay, my median, that's really sloppy. If it was 28, now we're going to add 3 to that, we get 31. Okay, and I think you get the idea. My mode, if it was 20, well, now I'm going to add 3 to that, and I get 23. Okay, so whenever we add a value, it has to happen to each value in the data set. If we just add something, or for that matter, subtract something, then we just, for the measures of center, you just add it or subtract it, whatever it is. Okay, and here's the nice thing. Look, for measures of variation, for our range, and for our standard deviation, I'm just going to write sigma, then they stay the same. They don't change at all. That's pretty nice. Okay, all right, let me make a quick comment before we move on to multiplication. Just let that sink in a little bit. But I want to show you one little thing. For those of you that are pretty investigative, you're good investigators. I don't know how to say that. All right, so if you happen to be looking somewhere, or if you even go in a standard calculator like this, it said whenever I found my standard deviation, it asked me, is it a population or is it a sample? Okay, so just reel back quickly to this dog height scenario. Whenever that gets into a lot of stuff. Population, there's only 5 dogs here, so that's why we used the formula that we did. Now, let's say this is actually just a sample of dogs. If that's the case, then there's a different symbol for that, and that's considered a sample. Okay, so the formula is going to be slightly different. I think they even show that here. Here we go. A small change with sample data. So the formula is just a little bit different. And so if you see, it's just written as an S. So if you see a different formula, here's the formula for population. That's the one we had. It's written a little differently. But if you see an S, like if you're using a program like on your calculator and you see S and you're like, wait a minute, that's because it's calculated a little bit differently. That think of a sample as like that. The reason the formula is different because it allows for a correction in your data when it's only a sample. Okay, that was my little side note while that other stuff settled. Last little bit then here is what happens when our data is transformed using multiplication. So maybe they don't go ahead and they don't say, oh, we're going to add $3 to everyone. Instead, they're going to add a percentage. So maybe they say we're going to increase everyone's salary by, because I like when salaries are increased, by 20%. Okay, so they add a percentage. They add 20% to everyone's salary. Oh, that erased funny. So I'll write it again. So that's my k value in this case. So when each value in the numerical data set is multiplied by real value k, when k is greater than 0, then the measures of the center variation can be found. by multiplying. Okay, so percentage, we know it can be written as a decimal. So what we're doing is we're multiplying and increasing every value by 20%. So it's going up by 20%. Okay, so there's two ways we can think about this. Let's first of all analyze this. It says the measures of center and variation are found by multiplying. Okay, so we do both of them. So let's say that our mean used to be, I'll make up another number, 45, totally making this up. Well, now, under the new circumstances, I'm going to multiply 45 by 0.2. Now, if you're doing this on your own, you're going to say, wait a minute, 45 times 0.2 is only $9. This person's new salary is not $9. And you're correct. It's increasing by $9. So that means 45 plus 9. So this person is now going to get paid $54. Okay. Sorry, this is the mean here. So the mean is now $54, not what person gets paid. So the mean, you just multiply it. Okay, so another way to think about that is some people say, well, if it's increasing by 20%, that's the same as saying it's 100% of what they used to have plus 20% that it's increased by. That's 120% or 1.2. So we could have done this same thing. Our mean was 45. Well, then I can do 45 times 1.2, and if I multiply those right off the bat, I'm going to get 54. Okay, so 45 times 1.2, and that gives me 54. So my new mean would be 54. Now you would do this for every one, the mean, the median, the mode, and range and standard deviation. Okay, right there. That might be a lot to take. Obviously, feel free to ask me questions. Let's try one out, though. I think that's where we like it most. So we're going to do numbers 5 and then this down here, and we're finished. So at first it says, find the value of the measures shown when each value is increased by 8. So we're only adding 8. So this is adding. If we think about that, that means these three things, we're just going to add 8 to, our measures of center. So 42 plus 8, my new mean is 50. 40 plus 8, my new median is going to be 48, and 38 plus 8, my new mode is going to be 46. Okay, now when we're adding, the range stays the same and the standard deviation stays the same, so those don't change at all. Okay, pretty nice. Everything stayed the same there. All right, so that's when you're adding. You keep the variation ones the same, but for the mean, for the measures of center, you're going to add whatever it is. Now, find the values of the measures shown when each value in the data set's increased by 30%. So this is when we multiply, okay? So I'm going to take the mean that we had before, so this is going with the original, 42, and I'm going to multiply it by 1.3. Again, I think this is easier if you just do 1.3, because this is really 100% of what the mean used to be, plus 30% increase. That's how you get 130%, or 1.3. Okay, so 42 times 1.3 is going to give me 54.6. I'm going to do the same thing with the mean, or the median. So 40 times 1.3. So my median used to be 1.3. My new median, with an increase to every point in the data set by 30%, is 52. For the mode, it was 38. I'm going to multiply that by 1.3. And 38 times 1.3 is 49.4. And now we're going to do these for the range and standard deviation too. So the range was 15 times 1.3. And that's going to increase to 19.5. And lastly, standard deviation is 4.9 times 1.3. This is what it's increasing by 130%. Sorry, increasing by 30%. I'm multiplying by 130%. And that is equal to my new standard deviation be 6.37. Okay, so the purpose here is, again, so you don't have to calculate the whole data set over again. You can just, if it's happening to all the numbers, then you can just use this little short formula. Okay, all right. There's only a few problems I'd like you to try on these. Give them a go. If you have any questions whatsoever, I know this is a little bit new, a little bit less familiar, but we tried to break it up. So see me if you have concerns, okay? Thanks, guys.